Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to talk about how we actually go about solving quadratics. So we looked at graphs of them last time, and technically you could graph a quadratic and try and see where the graph crosses the x-axis, and that would be the solution to it. But a lot of times those 2 points, or maybe point, will be really weird decimals and you just can't figure it out. So you need to be able to do it with like algebra. So that's what we're going to do today. So this first problem is just actually kind of going back to using some of the different forms. And it's just good practice of some stuff from last time. So first off, if I want to find the line of symmetry, you really only find the line of symmetry if it's in standard form like this one is. And it's just that little formula, x equals negative b over 2a. So b is 12, a is 2. So if you simplify that out, you get negative 3. So that's just the vertical line that cuts the curve in half, right? And so then I'm saying next, using the line of symmetry, find the vertex of the quadratic. So the vertex is a point, right? And we'll get the y value. We have the x value, but we'll get the y value from plugging in the x value. So if we plug this in, so if you simplify that out, you get negative 21. So the vertex is negative 3 comma negative 21. That's just like the turning point of the graph, right? Then there's the last one. So using what you know about vertex form, write this quadratic in vertex form. So if you have a vertex point, which we have now, and you have like this original graph, you know you can turn it into vertex form. The vertex form, again, is just like a number in front that represents like the scale factor, and then like plus or minus x plus or minus some number inside, and then plus or minus some number on the outside. And it's basically just built off of function transformation. So, if I have this negative 3, that's moved to the left 3. And the weird thing is that if you move it to the left, you actually put a plus 3 inside. And then I've got this minus 21, and that truly is going to represent like this number on the outside. So that number here always represents exactly how much down you move to for the graph, basically. So the only thing we're missing is the stretch factor, but that was actually just given up here. So all 3 forms of these, the a is always just the same exact value on the inside. Like if you go back and look at last video where I talk about the different forms of quadratics, I talked about how this value of this a is the same in all 3 different forms. So whether it's standard form or vertex form or the factored form, they would all have a 2 in front for this one. So actually, if you go, and it's good to do, I'm not going to do it the same, but if you plug this into like Desmos, and then plug this into Desmos, you will actually see that they are in the exact same spot. They are the same graph. So the real plan for today, like I said, is to talk about how we actually solve quadratics using some algebra. So technically, there's 4 ways to do this. There's factoring and the quadratic formula. Then there's graphing and completing the square. These 2 down here is not how I'm going to ever want you to solve a quadratic. Basically, what I write down here, this is probably one of the most important things that I write all year, because we're going to keep solving quadratics even in our other units a ton. Basically, this is how you want to do it. You try to factor any quadratic for I always tell students about 20 seconds. And then if you can't figure it out in 20 seconds, you just use the quadratic formula. And the quadratic formula, if you don't have it memorized, you're definitely going to have it memorized after this year because we're going to use it a ton. But you really need to know it. And I'll put it here again, I guess, just so people see what I'm talking about. So the A, B, and C's are, again, coming from just standard form. And so you just try to factor it. And then if you can, you just use quadratic formula. I would never want you to have, take the time to go and, graph a quadratic and then try to figure out like what these two numbers are. That's just like way too much work, because like what if 1 is here, 0.5 is there, and this is like maybe about 0.25, but it's like too hard to tell, so it's just the graphing is like a really not efficient way to solve them. This thing completing the square we will talk about. A lot of times you do this in Algebra 1, but you might have not learned it. But basically I'll teach you it from scratch, and it's really useful for a few things we do here, but not for solving quadratics. All right, so said this last time too, but it's really important, so we'll just say it again. So the solutions to a quadratic, basically there's three names for the same thing here. What we're doing, we're either finding, in simplest answer is we're finding the x-intercepts of the graph. Just like this picture down here, we're looking for these x-intercepts. And those are called zeros because the y value is 0. And they're also called roots of the quadratic. The reason they end up being so useful is like a lot of like just real world problems. You might have like a quadratic that represents some like projectile motion like this. And this just represents like the ground, like elevation of 0, right? And maybe your rocket or whatever the thing is goes up to like, 1,000 meters or something. And we want to know like this could be like time down here. And we want to know like, it launches at time 0 and then it goes up and up and up and then comes down. And we want to just know like what time does it hit the ground again. So the x-intercepts just were originally like the most useful things to find because they had the most like real world meaning. That's the idea. And to do that, we basically, again, I said this last time too, but we're really just taking, we might take like a quadratic like x squared minus 2x plus pi for no good reason. And we're basically just solving a system of equations where we, want to know when does y equals x squared minus 2x plus pi equal y equals 0. And so what that means is we're basically just, taking these two y values and we're just setting them equal. We're just doing like y equals y, and we're just going to take the quadratic and just set it equal to 0. And then we just solve for x, and because it's x squared, there's going to be two answers, and those are going to be your two roots. So, like I said, the best way to do this is factoring. It's just the best because it's the quickest. And so I actually have like a few examples I want to go over regarding factoring. And then I'll talk about how we can actually just solve some too. Solving them isn't that different because we basically just, we would have like these equations set equal to 0, and we would still just do all the work the same with the factoring, but then we just do one little step at the end. But for right now, I just want to factor. So, some of this should be algebra review, but it's been a while, so we're going to kind of go through it like from scratch here. So the idea, really comes out of just taking like, I don't know, what's a nice one? 12. Like you can factor the number 12 into two parts here, like 3 and 4, right? And we're basically just going to take this expression and we're going to split it up into two parts that if we multiplied them, we would get back to this. And so, this is, you've got to get to p squared in this one. So, the easiest way to just do that is p squared, or p times p is p squared, right? The number at the end you need to be able to multiply that when you put in your numbers here. And then the weird thing is you need to be able to add to this number right here. So this last part, you kind of have to think of two things at once. You have to think of what's going to multiply to this, right? When we do this out, it's got to multiply to that. But then when we go and combine like terms, what's going to add to this, right? So multiply, add. And, I'll just kind of put it down here, but sometimes it takes a little bit of like trial and error. Like it is minus 7 plus 2. There's a trick that I can kind of show you that might help. So if you see that it should be like a 7 and a 2 because you know that those numbers are going to get you to 5, but you aren't sure which one needs to be negative. The one that's negative is always the bigger of the two numbers always matches the sign of this. So 7 and 2, 7 is bigger than 2. And so this being a negative means that the 7, which is bigger, gets the negative, like that. But sometimes it just takes trial and error. Like maybe you thought it was, I'm going to erase this, but maybe you thought it was p plus 7 and then p minus 2. You just have to double distribute, try out all the multiplications and see what you get. You get p squared, you get minus 2p plus 7p, and then minus 14. And in that case, you would get plus 5b instead of minus. So you just have like the sign in the middle wrong. But you might just have to do this down here and just do the trial and error. I'm going to erase it. But the little shortcut, if you, the way that you can kind of think of it is you can look at this number and it's got to multiply to 14. So like, something like a 7 and a 2 could work. And then the sign of this always goes with whichever one's bigger. So the 7 was bigger, so that's the negative one, and then this one has to be positive. So for this other one, we would just start by splitting it up into 2b and b, because then you get 2b squared. There's technically other ways to multiply to 2b squared, but that would be the easiest way, so just do it that way. And then the number at the end, that it's got to multiply to 21. And you might just not be able to see it again here without some trial and error. So maybe you think it's like 1 and 21. And then if you just test it, you would get 2b squared, 21 times 2 is 42. B and then plus B plus 21. And so you would see that you're getting 43 B's in the middle, not 17. And so, then you can see okay, that wasn't the right one. And so you kind of just play around with it a little bit. And this is what I mean by if you can't do this in 20 seconds, then you'll just do quadratic formula and that's totally fine. But, and generally speaking, if this is a number here that's bigger than 1, like 2 is, it's always a little bit harder to figure that out, figure out how to factor it. But I typically try them when this is a prime number, or a 1. So 1's not technically prime, but if it's 1, 2, 3, 5, stuff like that, those are ones that are kind of nice because I know that the beginning terms will just be maybe if this was a 3, it'd be 3b and b. Or if this was a 5, it'd be 5b and b. And then you just got to play around with the numbers based off of this at the end. In this case, you might be sitting there being bored because you saw already the answer. But it would be 3 and 7. And you can always check it. There's actually a quick way to check because a lot of times you can see that the first ones multiply correctly and these numbers multiply to 21. So really you just need to check what they call, those two multiplications are what they call the cross terms. And the cross terms are really the tricky ones. It goes across because it's the second term to the first one and then the first one to the last one. So it's cross. But you can see here that this is 14. And then plus 3 is 17. So that's the kind of the check that I do. A lot of times I just check those multiplications because those are the really annoying ones. All right, so those are kind of straightforward cases, honestly. These two are sort of special cases for factoring. And for some reason, I've been teaching this course 8 years, and this one always puzzles people, but honestly, it's actually easier than any of the other ones because the only way to factor this is just all we're doing when we factor is we take out some common terms, right? And the common term is you can just take out a k. So you can do k times 7k plus 9. And that's literally taking the quadratic and splitting it up into two parts. And you could, just do normal single distribution, put that back in, the k back in, and you'll see that you get it. Really, if you want to think about it this way, what you're doing is you're doing k plus 0 times 7k plus 9, and the 0 times the 9 is why there's no number term, right? It's like 7k squared plus 9k plus 0. But honestly, I wouldn't even think about it this way. I wouldn't recommend you worry about that. Just if you see something in every term, then just take it out. You factored it. You can pull out the variable that's in these two. This is something that's really important, and it's called a difference of perfect squares. And difference of perfect squares is literally what it sounds like. It's like you have a number squared subtracted by another number squared. It is a, difference of two perfect squares. And if you ever see that, there's actually like a factoring trick. So this thing can factor into two terms again. And you can always start off by putting a plus and a minus, because that's like a thing that all these differences of perfect squares have. And then what you're just going to put in the first spot is like the square root of this number, or this expression, I should say. And then you're going to put in the second spot the square root of that. So you get 12x for that, 12x for that, and then you get 8 and 8. And that always works. Like if you had, I can just make up another one really quick. Let's say you had, 100x to the fourth minus 36. So that's a difference of perfect squares. You could do 10x squared plus 6 times 10x squared minus 6. And you'll see these, the PSATs, SATs, those kind of things love these kind of difference of perfect squares. They show up a ton on there. If you ever see them, just know that you can start off with the plus minus thing and then just put the square roots in here. Technically, the square root of 144x squared is not 12x. We will actually talk about it later on, but it's not super important right now. But just so you know, actually the square root of 144x squared is 12 times the absolute value of x. But let's not worry about that right now. But actually, if you can remember that right now, that would be really important, because in a few units from now, we're going to see this kind of stuff a lot. And it's important to know that that absolute value is there. All right, so the last thing I want to do is just show you how we can go about solving some. So these are two quadratics, different quadratics, and I would solve one with factoring and one with quadratic formula. And I would try to factor both. It just turns out that one of them factors really nice and quickly, and the other one doesn't. And the one that's nice is this one. Because the way I think about it is what multiplies to -3 and adds to -2. And it's probably not too hard on this one to see that would be -3 plus 1. And if we want to know when this thing equals 0, we just need to look at each little factor and just think, what do we plug in so that we get 0? So what -3 is 0? Well, that would be 3. And then what plus 1 is 0? And that's -1. And so the x-intercepts to this problem are just 3 and -1. That's all you got to do. What would you put in here to make this 0? And what would you put in here to make this 0? That's it. And that's factoring. That's all you got to do. It's really quick. This one, you would have to simplify it a little bit first. So I'm going to just move everything to one side. So I'm going to add 8p over and get -7p. And then -1 and get -11. And then this is one of those where, before I was saying if this isn't prime, it's pretty hard to factor. The reason it's hard is because it's not super clear what the first terms should be. Should it be a 5p and a 2p? Should it be a 10p and a 1p? It's just going to be too many cases, basically, to think about. So this is honestly one where once I would simplify it like that, I would probably just not even try to factor it. I would just move on to the quadratic formula. So, A is the 10, B is the -7, C is the -11. And then I'm just going to go to quadratic formula. I'm going to plug, the right things in. So -b plus or minus square root b squared minus 4ac all over 2a. And then if you plug this stuff in, you're going to get a 7 plus or minus 49 minus 4 times 10 times -11. And then 2 times 10. And if you simplify that, you should just get 7 plus or minus the square root of 489 over 20. And honestly, this is the best way to write the answer. Unless this square root was something really nice, like if it was square root of 36, then I would want you to go further, but there is no reason. It's just a weird decimal. I'll check it right now, actually. So it's 22.1 or something like that. But it's some infinite decimal. There's no reason that you would ever write this number any different. This is how everyone would write this number. So just leave it like that. Don't try to do anything else to it. So that's it. You either have to go to the annoying formula and plug things in, or you split it up with factoring and you just write whatever the opposite of these numbers basically would be for factoring to solve it. And that's it. And we're going to solve a lot of these things. So you want to make sure that you're really good with all this before we kind of move on. Our whole next unit uses it a ton. And it really just never goes away. It's literally all year long. You're going to just be solving quadratics left and right. So very important stuff to know how to do.